What if every nuclear weapon humanity has ever built went off at the same time? Would any planet in our solar system actually survive that? And more importantly, how powerful are nuclear weapons, really? Are they strong enough to destroy an entire planet? Okay, let's slow down for a second and really think about this. Right now, there are over 12,000 nuclear warheads on Earth. These are the most powerful weapons we've ever created. But this video isn't about whether we should use them. It's about something else. Something simpler and honestly a bit more unsettling. What would actually happen if we did? There's something interesting about us as humans. We're drawn to dangerous ideas, not because we need them, but simply because they exist. So today, we're going to explore one of those ideas. Not to destroy anything, but to understand just how resilient the universe around us really is. Let's start with the simplest case. Mercury, the smallest planet in the solar system, is basically a dense ball of rock with a massive metal core. And most importantly, it has almost no atmosphere. That one detail completely changes how a nuclear explosion behaves. On Earth, a nuclear blast is so destructive largely because of the air. The explosion superheats the atmosphere, creating a massive shockwave. That's what causes most of the damage. But on Mercury, no air means no real shockwave. No shockwave means no iconic mushroom cloud. Instead, most of the energy is released as radiation. X-rays and gamma rays, a silent, blinding flash, strong enough to vaporize the surface at the point of impact. But here's the more fascinating part. Mercury is extremely dense and rigid. So instead of absorbing the energy, it vibrates, like striking a massive metal bell. Seismic waves ripple across the entire planet, travel around it, and meet on the exact opposite side. There, they can crack the surface, trigger landslides, and even launch debris into space. So in the end, you don't destroy Mercury, you just make it ring. And honestly, for something as powerful as a nuclear weapon, that's surprisingly underwhelming. Now let's go to the exact opposite extreme. Venus. If Mercury is nothing, Venus is too much. Its atmosphere is insanely thick, with surface pressure about 90 times that of Earth. Standing on Venus would feel like being deep underwater. So what happens if a nuclear bomb detonates there? Well, we've actually tested something similar on Earth. Back in the 1950s, we detonated nuclear devices deep underwater. The result? Still destructive, but much more contained. And Venus takes that idea to another level. When the bomb explodes, the immense pressure of the atmosphere pushes back. It essentially crushes the explosion inward. Instead of expanding outward, you get a brief plasma bubble that collapses almost instantly. The thick clouds absorb most of the light. From space, you'd barely see more than a quick flash. And since Venus is already extremely hot, the explosion barely changes anything on a global scale. Dropping a nuclear bomb on Venus is like throwing a match into an already raging fire. So, in one place, the explosion is almost silent. In another, it gets swallowed entirely. Nuclear weapons aren't always as powerful as we imagine. And if that's true for these extremes, what about places closer to home, like the moon or even Earth itself? If there's one place that feels closest to home, it's the moon. It's right there. You can see it almost every night. And if a nuclear weapon detonated on its surface, it would look very similar to Mercury. No atmosphere, no shockwave, no mushroom cloud, just a blinding flash of radiation, X-rays and gamma rays, vaporizing the surface at the point of impact. But there's something different here that I personally find fascinating. The moon doesn't absorb energy the way Earth does. It's more rigid, more dry. So when a large explosion happens, the energy travels across the entire body as seismic waves, and the moon rings, not for seconds, but for hours, like striking a massive bell, floating in space. And the strange part is, this isn't just theory. Humans have already hit the moon. During the Apollo missions, astronauts deployed devices that fired projectiles into the surface to study seismic activity. It sounds a little crazy, but also a very human. Sometimes I wonder, is this constant need to experiment, even on other worlds, a sign of curiosity or something closer to recklessness? If one day we had the power to destroy something beyond Earth, would we actually do it? And then we come back to something more familiar, Earth. This is the one place where we don't have to imagine the effects of nuclear weapons because we've already seen them. Over 2,000 nuclear detonations have taken place on this planet, from deep underwater to high up in the atmosphere, and the consequences don't need much explanation. But if we take a step back and look at Earth purely as a physical object, the question becomes, could all the nuclear weapons we have today actually damage the planet itself? Feels like the answer should be yes, but surprisingly, it's not. Even if every single warhead detonated in one place, it would create an enormous explosion, a massive crater, but to Earth, it's barely a scratch. The planet wouldn't be destroyed, not even close. The thing that would be destroyed is us. And this is the part that really stays with me. We've built weapons capable of ending our own civilization, yet they're nowhere near powerful enough to truly harm the planet we live on. It's almost like we've created something that can destroy ourselves, but not the world around us. There's something deeply ironic about that. If all those weapons went off, we could trigger a nuclear winter, the sky filled with smoke and dust, sunlight blocked out, temperatures drop, ecosystems collapse, not because Earth dies, but because it stops being livable for us. So maybe the real question isn't, can we destroy Earth? But how quickly could we destroy ourselves? What do you think? If every nuclear weapon went off at once, what would happen first? And if even Earth, where nuclear weapons are at their most effective, can't be destroyed, what happens if we try that somewhere else? Somewhere we've actually imagined changing completely, Mars. Now let's move to a place that humans don't just want to explore, but actually want to change. Mars. Cold, dry, and almost completely uninhabitable. But here's the interesting part. There have been serious discussions about using nuclear weapons to warm it up. It sounds like science fiction, but not entirely. The idea is simple. Detonate nuclear bombs at the poles, release the frozen CO2, trigger a greenhouse effect, and slowly warm the planet. On paper, it makes sense. It even sounds clever. But in reality, it doesn't quite work that way. Mars does have an atmosphere, but it's thin, and it's extremely dusty. A nuclear explosion would create a shockwave, not as strong as Earth's, but still significant. But the real issue is this. It would throw massive amounts of dust into the atmosphere, and dust blocks sunlight. Enough dust in the sky, and you start cutting off the sun. So instead of warming the planet, you cool it down, a kind of nuclear winter. But on Mars, you try to heat it up and end up making it even colder. And this is something I find really interesting. A lot of human ideas look perfectly logical on paper, but when applied to something as complex as a planet, things rarely go as planned. It's almost like we tend to underestimate how resilient and complicated nature really is. Even if you ignore the dust problem, there's another issue. There simply isn't enough CO2 on Mars to create a thick atmosphere. Even in the best case scenario, you still wouldn't get anything close to Earth-like conditions. So in a way, the plan doesn't just fail slightly, it fails fundamentally. And this makes me think about something else. Maybe we're not just trying to find another world, we're trying to turn another world into Earth. But is that really the right approach? Or are we just trying to force the universe to fit us? And there's one more thing. The polar regions of Mars aren't just ice, they're archives. They hold records of ancient climates, possibly chemical traces of past life. A nuclear explosion wouldn't just change the planet. It could erase that history forever. So here's something I want you to think about. If you had the power to make another planet habitable for humans, but the cost was destroying its natural history, would you do it? Maybe Mars isn't a project to fix. Maybe it's a world to understand. And if even warming a relatively small planet like Mars is this difficult, what happens when we try something similar on something much, much bigger, like Jupiter? If you really wanted to bomb a planet, you'd probably want to pick something worthy of that scale. Jupiter, the largest planet in the solar system, more massive than all the others combined. Not just big, overwhelming. Now imagine this. You take all 12,000 nuclear warheads on Earth, load them onto one massive vessel, and detonate them all at once inside Jupiter's atmosphere. A human-made explosion on a scale never seen before. Blinding light, extreme heat, a massive fireball forms, and then it's gone. Within seconds, no global shockwave, no surface to push against, just gas. Thousands of kilometers of it. Everything you just created gets absorbed, dissipated, and swallowed like it never happened. And I think this is the moment where something starts to sink in. The most powerful weapons we've ever built can become completely meaningless at a cosmic scale. If you're thinking, maybe we just need more, then this number might stop you. To destroy Jupiter, you wouldn't need twice as many nukes, or 100 times more. You'd need around 100 quadrillion times our entire nuclear arsenal. Take a second to process that. That's not difficult. That's impossible. Even getting a bomb to Jupiter's core would be nearly unthinkable. The pressure would crush anything. The temperature, hotter than the surface of many stars. You wouldn't even get a chance to detonate. Honestly, trying to blow up Jupiter is like an ant trying to move a mountain. And if that still doesn't convince you, this already happened. In 1994, a comet slammed into Jupiter with the energy of hundreds of millions of nuclear bombs. Plumes shot thousands of kilometers into the atmosphere. Temperatures soared to tens of thousands of degrees. It left massive scars, visible even from Earth. And the result? Jupiter stayed Jupiter. No explosion, no collapse, just a bruise. A bruise from something that could wipe out our entire civilization. And Saturn? Pretty much the same story. You detonate something there, and it gets absorbed. No solid surface, no dramatic destruction, just energy disappearing into the system. But Saturn has something else. Its rings, billions of icy fragments, spanning vast distances. If a nuclear explosion happened there, you'd actually see something dramatic. A gap blasted open, ice vaporized, fragments scattered, a visible scar in the rings. But then, within days, everything settles back. Particles reorganize. The gap disappears, like nothing ever happened. And I think that's what makes this part so fascinating. At a human scale, a nuclear explosion is the end. At a planetary scale, it's just noise, a ripple in something far too large to notice. So if even giant planets like these barely react to what we do, is there anything in the solar system that actually would? After everything we've seen so far, you might be thinking, okay, so nothing really gets affected. And you're almost right, but there are still some interesting cases. Uranus and Neptune, ice giants, with massive pressure deep inside. If a nuclear explosion happened there, something strange could occur. The pressure could break apart methane and compress carbon into diamonds. Instead of destruction, you might get something unexpected, a diamond storm. And I don't know about you, but there's something fascinating about that. Even when we try to destroy something, we sometimes end up creating something else. Now, if we go smaller, Pluto, a frozen world at the edge of the solar system. Here, the explosion would behave more like Mercury. No real atmosphere, no massive shockwave. But with ice involved, you'd get a cloud of vaporized material, spreading into space. A brief flash, like a tiny supernova. Beautiful, short-lived, gone almost instantly. And then, the ultimate scale, the sun. If you tried to send a nuclear weapon there, it likely wouldn't even survive the journey. But let's say, somehow, it detonates. The result? Almost nothing. The sun is already a massive nuclear reaction. Every second, it releases energy, billions of times greater than any weapon we've ever built. Dropping a bomb into the sun is like throwing a spark into a raging furnace. And this is where it really hits. Throughout this entire video, we've nuked almost everything in the solar system. And what did we learn? Nuclear weapons, the most powerful things we've ever created, are only truly devastating when used against ourselves. To the universe, they barely matter. And I think that's the most humbling part. Not how powerful these weapons are, but how limited they really are. We like to think we control something massive, but in reality, we're operating on a very small scale. But if you really want to see a nuclear weapon make a difference, there is a better target. A comet, an asteroid, objects small enough that we might actually be able to affect them, not to destroy, but to protect Earth. So maybe the real question is, if our power only truly matters on things smaller than us, what should we use that power for? And if you thought these explosions were impressive, imagine what happens when two stars collide. But that is a story for another time.